Good evening, we enthusiasts. So today we're going to start 12th standard topics, and I'm going to make sure that you revise all the 12th standard topics in these series. Like we have started 11th standard topics, we are also simultaneously starting the 12th standard topics on generally Thursdays, Fridays and Saturdays. That's what we are going to do. That's the plan. And all the 12th standard and all the dropper students, now you should be really happy about this. So today we are going to start with electrostatics, the conductors, the forces, the different properties, many questions on that, and also gravitation, because both chapters should be studied together. If you are studying it separately, it will consume a lot of time. I feel all the formulas for electromagnetism and gravitation are very identical to each other. So I feel we should study both these chapters together, and that's why I am here, guys. Welcome aboard. This is Shreyas here, your master teacher for physics at Vedantu. All the new members, welcome to this family, and today onwards we are going to also start the 12th standard series. So please understand, guys, those who are in 11th standard, we are still continuing the 11th standard portions. We are going to start with rotation next. I think last time I completed center of mass. So the next chapter will be momentum, and then we'll continue with rotation and then SHM. So do not worry about that. That will happen on Mondays, Tuesdays, Wednesdays generally. And on Thursdays, Fridays, Saturdays, we'll continue with electrostatics. Then we'll go to magnetism, then electromagnetic induction, AC circuits and all those topics. So I'm going to cover it all. So do not worry, before your exams you'll be very well prepared, and I'm pretty sure you will score really good ranks, just like the ranks that I have produced in my previous years of teaching. Alright, so you can also get in touch with me on my Instagram handle Shreyas_Vedantu. That's where you can get in touch, and I post a lot of updates about the upcoming lectures and some interesting videos which you might like. So having said that, if you are a new user, do not forget to subscribe, and even if you are an existing user, do not forget to like, guys, because the way YouTube works is if you like and subscribe, only then our videos will pop out, or you'll be missing out some interesting sessions. Like yesterday Shreyas Sir conducted a lecture on what is life in IIT. Day before yesterday, I think I conducted a lecture on how is life how is cricket related to physics and all that, and then so many other lectures which we all three of us conduct. You'll be missing out on that, so do not forget to subscribe and like, and also share it with your friends. All right, so also let me make a very important announcement, guys. The sale of Diwali has been extended, yes, for all of you. So all those of you, because a lot of queries came in the midnight, sir, please, we want to join the pro subscription, please extend the sale. So we were like, okay, fine, let's extend the sale. So a lot of comments, a lot of people have messaged, so that's why we extended the sale, guys. So the pro subscription course, which gives you live teaching, tests, assignments, these tests are nationwide test series, and online everything, and you also get report cards, you also get personal mentors, teachers, well qualified teachers, options of learning in Hindi, English, and also, guys, you get the additional courses, the micro courses, all this at a very affordable price. The 50% offer is still valid. We have extended it till 15 November now, only because of you, because all of your comments and all of your all of your requests and all that. That's why we extended the sale. So these are the prices for the 2021, the 12th standard students. Okay, the next slide is for the 11th standard students. You can see for the 12th standard students, for 6 months the price is 39,000. you will get 50% off. The cap limit is 10,000, of course, but it's a very good offer which I think you should not resist, or you should not even try and stop yourself from enrolling right away. Okay, and also the 11th standard students, again the price for 6 months is 24,000 rupees. Again you get 50% off with a cap limit of 10,000. Do not hesitate to join right away. I will give you the coupon code, and this is for the droppers. So the droppers, we will prepare you for all the exams, mains, bits, whatever it is. So you can take the 6-month subscription, which is 51,000. Again you get 50% off. Okay, that's a big amount, again with a cap limit of 10,000, and the coupon code is SHHPRO. So that's how you get the discount. Without this coupon code, you will not get the discount. So you can pass it on to your friends also if they need it. the link for subscribing and the link for all kinds of information that you will ever need is there in the description box below. So use that link, use this coupon code, only then you'll get the offer. So let me just say hello to everyone. All right, welcome. So yes, this course is for 12th and droppers, whatever we are going to do today. Yeah, so whatever we are going to do today, the capacitors, the charges and the properties, all the electrostatics, we are starting the 12th standard portion today itself. So in physics, this is what we're going to do. On Monday, Tuesday, Wednesdays, generally I'm going to keep it 11th standard portion. On Thursdays, Fridays, Saturdays, generally I'm reserving it for the 12th standard and the dropper students. Alright, but if a 11th standard student wants to attend the 12th standard class, feel free, you can revise all the concepts, and I'm guessing that will also help you for your KVPY preparation. Yes, or Olympiad preparation. If you're preparing for Olympiads or KVPY, this is definitely going to help you. Alright, yes, Yamanandla, I'll be covering all the concepts. These are little bit fast-paced courses because this is for 12th standard and dropper, and we just have 2 to 3 months. Remember, very little time left before the exam, but we will not do it one-shot types where the entire chapter is completed in one lecture. Guys, that is not possible for chapters like electromagnetism because these chapters are huge, and a lot of people do that, I know. But I'm not going to do it that way. I'm going to accumulate few topics in electrostatics and we are going to cover it in one lecture. That's something what we'll do. But we'll not complete electrostatics in one lecture. That is not possible because understand, right now we have time. If it was just 15 or 20 days before the exam, then it made sense. But now we have 2 to 3 months. I'm pretty sure the way I have planned, I can complete the entire 12th standard portion. Alright, I hope this is clear. Okay, so this is kind of an extended crash course, you can think of it, Suhas. A very extended crash course. It's not crash course, it's like an extended crash course. You can think of it this way. Alright, because crash courses generally start just 1-2 months in advance. Alright, is this fine, guys? Are you guys with me? Are you guys liking this concept? Are you guys with me? Are you guys fully supportive of this idea? Because we have read all your comments and we want to support all the 11th, 12th and dropper students. We are here for everyone. Please understand that, who want to crack the JEE examination. Be 21, 22, doesn't matter. Yes, are you guys with me? Very good. The Josh is high. So please hit the like button if you are with me, and if you are supporting our channel, please subscribe to our channel as well. That red box on the side over here. Alright, so let's begin. Even if you're a NEET aspirant, it's okay. You are welcome to attend physics lectures over here. Alright. Okay. Yes, Kirito, yes, Hoin, welcome, Kiriti, Poetry, Pranati. Let's begin. So, guys, please keep a pen and paper in handy because I'm going to give a lot of formulas, so you have to write it down, okay? So, keep a pen, paper, calculator, whatever you want, keep it in handy. So, we are going to start with basic properties of charges. Like we all know, like charges repel and opposite charges will attract each other. So positive, negative will repel, but opposite charges obviously attract each other. That's a basic fundamental property of a charge which everybody knows. This was discovered long time back. And I will compare it now with gravitation. Remember, I'm studying gravitation and electrostatics in parallel. So let's study both of them together. So in case of masses, it's quite interesting that they only can attract each other. Like charges can be positive or negative. Masses in JEE are not positive or negative, they are only positive masses, and masses will always attract each other, they will not repel each other. Although there are talks about dark matter and negative masses, let's ignore that for now. We can keep it for some other day. But in JEE syllabus we do not have negative masses or dark matter, so do not worry about it. So we just have these masses which attract each other. Okay, now the next thing, addition. Charges have sign. Okay, charges have sign like plus or minus. In spite of that, they are not vectors, guys, they are only scalars, because the direction of a charge is not defined and it is meaningless. It's just a value, and when you have 2 or more or 5 charges on it, understand, on a body, you can just add the charges without worrying about the direction, because charge does not have direction, simply put. So if you have 2 or more charges, okay, say for example something like this, let's say this is 2 2 coulomb charge. Let's say this is minus 5 coulomb charge. Charge is measured in coulombs, mass is measured in kgs. I hope you know that. Coulombs is the unit of charge. And let's say this charge is, let's say, 1 coulomb. So then if I add all of them, 2 minus 5 is minus 3, and minus 3 plus 1 is nothing but minus 2. So this is the total charge of it. So that's just the addition. So if it is negative, just take the minus sign. If it is positive, take the positive sign. Is this clear, guys? Yes. Very good. Now let's talk about the next property. Okay, so guys, come on, I'm going to slowly build up the base. You will see slowly I'll start the questions, and pay attention. The questions are very interesting. They are going to open up your mind. So stay tuned till the end of the session. You will see what kind of questions we are going to ask. Next property is quantization. Very important property. The smallest possible charge. This quantization says that the smallest possible charge is how much? It is 1.6 into 10 to the power minus 19 coulomb. And this charge can be of an electron or of a proton. For electron, that is negative. For a proton, it is positive 1.6. That's the smallest possible charge possible. So any charge that is there on a body or on any other thing, understand, will be a multiple of this charge. That there is a very famous experiment called as the Millikan oil drop experiment and all that. So, you know, people have proved that charges are always multiples of the most elementary charge. So you can have 1e, 2e, 3, n times of each charge, but you cannot have a charge like say 2 into 10 to the power minus 19 coulomb. This charge is never possible. Why is it not possible? Because it is not n times of e. It is not, where n is an integer. It is not. Simply put, this is not possible. Is this understood? Everyone with me? Give a thumbs up. Come on, give a thumbs up if you guys have understood, or put a yo in the chat box. So as we'll talk about black holes and white holes on a separate day. Right now let's focus on J, right? Because a lot of people just get carried away. They are very interesting topics, I believe, I understand. But let's keep it for some other day. Let's understand, let's keep some special sessions for all of that. Alright, Suhas? So let's get with the syllabus right now. Okay, very good. Look at those smileys, look at those thumbs up. Very good, MK, Juhi, Poetry, Pranuti, Mohammad. Excellent, Jumna. Excellent. Now, next property, conservation of charge. Again, an important property. If I have a system which is isolated, just hold on a second, the lights have gone. Okay, so I just turned off that noise, or else that UPS will keep beeping. The electricity just went off, it's okay. So if the system is isolated, then imagine if this body has some charge, let's say plus 2, this body has some charge, let's say plus 1, and let's say this body has some charge, let's say minus 5. Example. So count the total amount of charge. 2 plus 1, 3. 3 minus 5, minus 2. So this is the initial charge. So this is the initial charge which is there on the isolated system. Now let's say they touch each other, they exchange charges with each other, something happens. Eventually the charges will change. Even after the exchange of charges, the total charge will remain the same. The total charge should still remain minus 2. So for example, this becomes minus 3. This becomes minus 2. Example. Alright. So how much charge will be there on this? Just add it up. Minus 3 minus 2 is how much? Minus 5. Correct? This is minus 5. But the total charge should be minus 2. So if this is minus 5, what charge should be there here so that it will become minus 2, guys? Come on, very good. Plus 3, all of you have already answered it. Excellent. So this is nothing but charge conservation. Net charge in an isolated means the charges cannot move out nor can they enter in, is always constant. So that's the charge conservation property. Next, uniform distribution property. This is very important property only for conductors. What is a conductor? Conductor is a body where the charges can move around freely. They can move around anywhere that they want. Insulators are those bodies like plastic, wood, etc. Charges are not allowed to move freely. So examples of conductors will be copper, aluminium, silver, gold, iron. All these are conductors. They have free electrons. They can readily realign the charges. But plastic, wood, all these objects cannot realign their charges. So now, if you understand that, imagine if I put some charges on a conductor, like a metallic object, okay? What will these charges do? They will try to move away from each other. So once they try to move away from each other, what will happen? They will redistribute and they will be as far away as possible. And when they finally settle down, you will see the charges on a conductor. If it is a spherical body, it will be uniformly distributed. So understand, this distribution is uniform only on a spherical body like this one. But even on the sphere, understand, these charges are not exactly inside. No, they are not exactly inside. They are only on the surface. So think, imagine you have a big metallic sphere size of the earth. Okay, imagine a big metallic sphere of the size of the earth. If you charge it, what will happen? You will see all the charges will be only on the surface. There will be nothing inside the earth. Why? Because they are all trying to move away. So remember, these charges, alright, these charges are only on the surface because they will repel each other always. So charges on a conductor are always on the surface. In fact, this is one important property. So charges, not just for a sphere, for anything, charges on a conductor are always on the surface, not on the metallic part, not inside the metallic part. So always on the exposed surface, that's where you will see all the charges. All right, very good, very good, very good. Is this understood, everyone? Is this clear? Are all these properties clear? Shall we go ahead? Next property, charges on a non-uniform body or a body which is not spherical. This is very important property. Not many people know this. Let me tell you, if you have some body which is not spherical, then charges are not going to be distributed uniformly. In fact, they get accumulated near the bends. Yes, near the bends. Bends means where the sharp edges are there. So this is a sharp edge. You will see more charges will be there here. Wherever the edges are blunt, there you will see less charges are accumulated. In fact, there is a term called as surface charge density, the surface charge density and the radius of curvature are always inversely related to each other. They are inversely related to each other. What I mean by radius of curvature? Radius of curvature means this one. This one. This is the radius of curvature. And surface charge density means if I take a patch on the surface, how much charge is there per unit area? So Q by A is called as sigma. So that is the surface charge density. So understand, sigma is inversely proportional to radius of curvature. This is a very, very important rule. You should know this. Okay, remember this. So whenever you have spherical surfaces like this, so then the charge per unit area is inversely proportional to the radius. Wherever r is big, surface charge density is less. Wherever r is small, that is it is sharp, you will see sigma will be very large. Very important rule. Yes, so that's why if radius is not uniform, surface charge density will keep changing. Yes, this is always outside charge. There is no charge inside the conductor. Remember, that was the rule before this. There is no charge inside a conductor. All the charges always get accumulated on the surfaces. Nothing is there inside. Yes, Yamandala, I just told you, right? I will cover all the concepts I just told. Okay. 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 Yes, these surfaces need, okay, so whenever I talk about this radius should be the radius of curvature of that spherical part. So you can take a curved surface, and that curved surface can be thought of to be made to be a part of a big sphere. So that r is the radius of that big sphere which the curved surface is a part of. That's what I mean. All right? Okay. Now, next thing, let's go ahead. So charge density ρ is nothing but charge per unit area. So if you imagine this remote, if there is some charge on this surface, that is charge per unit area, that is charge density. All right? And line wire, Suhas, will be coming to it in Gauss's law, not today. All right? Okay. Now let's talk about transfer of charges. So understand, only in conductors the charges can move from one body to the other body when you touch them. What am I saying? Only in conductors. In conductors, charges transfer when touched or connected by a wire. So that is the only way the charges can move from one conductor to the other. Either you touch them or you connect it with a wire, or there is some another conductor in between them which is transferring or helping their charges. That's one way of transferring the charges from one conductor to the other. So when you touch, let's say this conductor has a lot of charge, this has less charge, they will redistribute the charges, and once they redistribute, understand, very important thing, they will behave like one single conductor. This is like one single conductor. There will be one single conductor. Will the charges on both of them be equal? What do you guys say? Do you think the charges will be equal on both of them? What do you say? What do you guys say? Will the charges be equal in all situations? No, it will not be equal. Understand, it will not be equal. Why? Because the spheres might not be of the same radius. Only if they are of the same radius, the spheres will have same charges. In fact, you can think that yes, because it forms one single conductor, it's like, forget that red and green, it's one single shade. Understand, the charge per unit area will be, remember, inversely proportional to the radius of curvature. So what if one sphere was big and one sphere was small? Don't you see that the charges on both of them will not be equal? It will be in fact different. I hope you can see that. The charges won't be equal. In fact, you can calculate this using this principle. Is it clear, everyone? So the charges won't be equal if the radii are not equal. Only if the spheres have the same radius, only in that special case they will be equal. Very interesting property. Okay, so remember all these things. I am giving you all these things because, guys, next week we are going to conduct a very big quiz. Only problem session that will be called as Menti quiz, where all these concepts will be put to use and you'll be solving problems and your names can come up on the leaderboard. Yes, it will be a live quiz where all of you will come and we'll conduct this quiz for you, all the dropper and all the 12th standard and even the 11th standard students who are interested in Olympiads can join in nevertheless. So understand, this is going to be a big quiz for all the people. Yes, charges can only lead when there is a conducting surface around it. Next, induction. First method of transfer was what was it called? Yes, direct contact. So using a wire or direct contact. Second method is induction. So what is induction? So let's say you have a charged sphere, okay? This is a charged metallic sphere, it is positively charged. Look at this other sphere. This is not charged at all, this is neutral completely. It's some another metal and it is not charged. Now they are really far away. This metal does not know this metal exists. They are very far away for them to attract each other or repel each other. Now when they are brought close, what will happen? These positive charges will repel the electrons in these metals. They will repel, right? So there are a lot of free electrons. So what will happen? All the electrons will go there, and once the electrons will repel, you will see there will be an exposed positive surface. So that's what will happen. So the moment you bring these things close, you will see the electrons. So the electrons have ran away. So there is flow of electrons because they are repelled by the charges. Alright, and in this big positive charge also, you will see that even those positive charges will be repelled away by these positive charges. So some of them will also move over here, but yes, there should be more positive over here than the negative because the charge has to be conserved. So some of the positive charges are also going to flow in this. Oh, sorry, my bad. Some of the negative charges are also going to flow like this, because they will be attracted by this positive charge. See if you are able to understand. Again, this is flow of electrons. Remember, in a conductor is only the electrons which flow, protons never move. They always are inside the nucleus. The outer electrons, free electrons, are the ones which move from one side to the other side. So this is what happens. This is called as induction. So when they will be equal, because think about it, sigma is inversely proportional to R. If R is same, sigma will be same. All right, very good. Now if you are understanding all these things, let me also tell you what is this called. This is called as induced charge. What is this called? This is called as induced charge. But even this is also induced charge, but it's oppositely charged. Okay, so this is also induced charges. So why have induced charges occurred? Because the moment this positive charge came, all these electrons ran away. Actually, I should have shown this ulta. I think this diagram is completely ulta, guys. I just realized ये पूरा उल्टा होना चाहिए था. Yes, this was completely ulta. ये positive था, and these were electrons. They should have actually come this side. Wait a minute. I'm just going to draw another diagram. Just one second. Just one second. I just realized it now. Actually, ये उल्टा होना चाहिए था. So when this comes here, yes. So what should have happened is that the electrons will actually not run away, guys. I'm so sorry. Yes. So these electrons, I don't know why that mistake was there in the slide. So these electrons should come close. They will like these protons. So they will come close over here. And the moment these electrons come over here, so when there is flow, you will have positive charges equal in number. If 1, 2, 3, 4, 5, 6 are shown, 1, 2, 3, 4, 5 and 6 protons should be shown on this side. So these electrons will like these positive charges, so that's why they will get attracted and they will come close over here. And these positive charges will also come close because they want to meet these electrons, but they cannot flow because there is a gap. There is a gap. There is no conducting wire. They are not touching each other, but they will come close. That's what will happen. And you might have few negative charges here. That's what will happen. Is that now understood? Is it clear? So poetry, what happened? Because there are electrons in this. Remember, there is positive, there is negative in an atom. Positive, negative, positive, negative. So what happened when you brought this? All the electrons in this particular green body, they came close to the positive charge. And you will see there will be an exposed positive charge. So these are again induced charges. These are all induced charges. No problem. Okay, very good. Chalo, let's go to the next one. So guys, this diagram is wrong. So please cancel this. I'll probably erase this slide later on. Okay. Now, insulators, I've just told you what insulators are. Insulators are those bodies which do not have free electrons within them. Okay, glass, plastic, ceramic, rubber, wool, wood, paper, all these things are examples of insulators. Now, do you think in insulators induction can happen? Do you think insulators can also have induction? What do you guys say? Insulators, can it have induction? Come on, guys. Yes, Mohammed, why not? Yes, you can follow me blindly. So people have been following me blindly, that's why they have cracked the exam, right? So do not worry, just have faith. If you have 100% faith, then it is possible. Even if you have 99.9% faith, it is not possible. Let me tell you that. So you should have 100% faith. Just follow whatever I am telling and whatever other teachers are telling. Current won't flow, no induction. Induction means not touching. Induction means they are close to each other. So when this is a rubber body, this is some another rubber charged body. When you bring these bodies together, do you think charges will flow? I don't think charges will flow, but there is one very special thing will happens, and let me tell you that. See guys, this is, let's say, example rubber, example insulators, right? Now inside this, what will you have? You will have many atoms. Atoms are nothing but positive charges, which are the nucleus. And you will have those electrons running around them like this, right? So you will have positive charge inside and you will have those negative charges running around them. So effective charge of the atom, what is the effective charge of the atom? 0. So if each atom has 0 charge, the net charge on the rubber is also 0. Now what happens is, guys, the moment you bring both these bodies close to each other, this positive charge will start attracting the electrons in the orbit. Yes, it will lose its mind, it will get carried away, it will get distracted. All this while it was chill, it was just roaming around its own nucleus. That's what has happened. So what will happen the moment this atom sees these positive charges are close by? What will happen? The nucleus is not affected, but these electrons will now start revolving like this. Look at the way they have changed their orbits. The electrons are more on this side than over here. So do you see a shift in the separation between positive and negative charges? So you will see earlier the positive and negative were at the same place. But now what will happen? The negative will be here, positive will be here, and there is a charge separation. There is a charge separation, and that will happen everywhere. Every electron will try to separate from the nucleus, but it won't, but that's what will happen. So yes, even in insulators, charges are induced, but is it as much as it was in conductors? No. In conductors, the charges actually moved from one place to the other, but in insulators, they hardly move, they just realign their orbits, so the induction is quite less, but it is there. Remember that. Okay, so very important, very important. Insulators can also have induction. So again, I think this diagram is wrong. I'll just have to erase this. I'm not sure why this diagram is wrong. Anyways, so when you bring these two things together, I'll just show you the diagram, what will happen, how will it look like. So when you bring them close to each other, you will see that these positive charges on the red body are still there intact. Remember, these are insulators, they cannot flow anywhere. But on the green body, you will see some charge separation, something like this, minus plus, minus plus, minus plus, minus plus, something like that. Okay, so you will see some charge separation over there. Okay, so that's what will happen. Is this clear, everyone? Are you guys now ready for some problems? Yes, they are not strong side. Very good. Okay, chalo. Let's go ahead then. Let's go ahead. If you're liking this session, please like it below. Yes, if you're liking this session, please like it below over there. Let's start with some problems now. Here is the question. I'm going to give you 1 minute for this question. Let's see how many of you can get this. So 1 minute for this question, and I'll just read the question and then start the timer. A charge Q1 exerts some force on a second charge Q2. If the third charge Q3 is brought near, then the force of Q1 exerted on Q2 will, options are given, think about it and tell me the answer, starting it now. Mr. Best, nobody knows. If somebody is telling you that JEE registration or JEE exam will happen right now or it will not happen, they are lying. Understand? So do not listen to anyone. Nobody knows except for the government and the board which decides when the exam will happen. So do not listen to anybody who will tell that JEE exam will happen now or it will not happen then or registrations will not open up. They are all lying. Understand that. Okay, I can see the answers coming up. कोई बात नहीं मोहम्मद. अच्छा, let's see. Yeah, those are all rumors, Mr. Beast. Don't worry. Those are all rumors, articles. ऐसे मतलब that was just for TRP and just to popularize that author or the newspaper. Don't worry about it. Okay, let's have a look. The correct answer, guys, is remains unchanged. Now I'll tell you why. See, the thing is, if you have, this is charge 1 and if you have this as charge number 2, charge 1 exerts some force on the second charge. Yes, obviously. So this is some force. Let's say I call it force by charge 1 on charge number 2. Now, the moment you bring another charge number 3, this charge 3 will also exert a force on 2. But that does not mean the original charge between 1 and 2 changed. No, the original charge is still the same. Just that this thing over here, charge 2, will experience a net force. It will experience a net force because of these two red and green arrow marks. But understand, the force between 1 and 2 is still the same. It will not be affected. Is this clear? Yes, this is very, very important property. This is called a superposition. Superposition means even if you bring more charges here, the individual charges ka beech mein ka force will not be affected. It will still remain the same. Yes, the net force will change, but whatever is there between individual charges will not change. Okay, very good, guys. Some of you have given the correct answer. Let's go to the next question now. Are you guys ready for the next question? A lot of objective questions coming in. So this is a complete strategy change for the 12th standard and the dropper students. I'll teach theory plus questions. A lot of questions out there. Very good. Let's go ahead. Two identical conductors. Again, I'll start the timer in some time. A and B are neutral. Okay, identical conductors are neutral and then charged to the same magnitude. But A is charged positively and B is charged negatively. Then whose mass is more? Starting the timer now. Yes, correct, Sayed. Suhas, we have assumed it as point charges. That's why. Let's see. Most of you guys, come on, think carefully. Think carefully, guys. Think carefully. Very few people have probably got the correct answer, I must say. And the time is going to be up. Okay, the correct answer is option A, guys. Think about it, I'll tell you why. See, guys, A and B were identical neutral bodies, so no charge on them. Now, if you put negative charge on A, what does it mean? You have added electrons. But if there is positive charge on B, then what does it mean? You have taken away the electrons. And won't electrons have some mass? Obviously they will have mass. So remember, when a body is positively charged, you are not adding protons, you are taking away electrons. That's the concept used. So when you take away electrons, what will happen? The mass will reduce. And here, when you add something, understand the mass will increase. यहाँ पर शायद इन्होंने गलत दिया है. Oh sorry, A was positive over here. So it's the other way around. I'll just erase it like this. Yeah, and I will write it here. This was B and this was A. Now it makes sense. Okay. So A was positive and B was negative. So that's the reason why A will have less mass than that of B. Is this understood? What an important concept. See guys, these kind of questions will come in JEE Mains, NEET exam, your BITSAT exam, your CET exam, and if you attend all these classes, you will get all these concepts and you will be able to crack those kind of questions. Without these kind of questions, I know a lot of coaching institutes do not discuss these kind of questions, and these concepts are not even clear, and they talk about very high Erudov level problems, Krotov level problems. Yeah, first put your feet on the ground and then we talk about Krotov and Erudov and other high level stuff, no? So guys, first build your basics strong, and that's what we are doing here. So trust me, I am going to make you clear mains, and then once the foundation, first floor, second floor is built, we are going to build a big skyscraper, guys. Yes, trust on me. Very good. Chalo, let's go to the next question. Again, two charges A and B, identical conductors, are neutral, same situation like before, and then they are charged to the same magnitude. But A is charged positively, B is charged negatively. If they are touched, then what do you think will happen? Multiple options are correct. This is advanced type question. More than one option can be correct. So I'll still keep the timer at 1 minute. Let's see how many of you get it. More than one can be correct. Yes, electrons have less weight, but that was the precise point. Even if there is a small difference, is the difference there? That's what the examiner was checking. Yes, dummy, but that is exactly what the examiner was checking in the previous question. Yes, Mr. Best, in JEE such basic questions also come. Oh, sorry. The question changed, my bad. I think. I don't know what has happened. Okay. So, okay. So, let's see what the correct answer should be. Two bodies, A and B, neutral, and they are charged same magnitude, but A is positive, B is negative. What will happen if they are touched? The correct answers are A, B, and D. That's what the slide says. Let's see whether that is also correct. So let's start with the basics. This is A, this is B, okay, and one sec. Now they are touched. This is after touching, okay. So this was before. Now before touching, let's see what were the charges on them. A was positive, so A was positive. B was negative, but of the same magnitude. Same magnitude, opposite charges. Now, if they are touched, what will happen? These electrons from here will jump like this, correct? These electrons will jump, and this will have zero charge, and this will also have zero charge, only because amount of positive and amount of negative was equal. So, look at the options. They will become neutral, yes, because both of them will have zero charge. A's mass will increase. Why will A's mass increase? Because the electrons from B are going to A. So if electrons go from B to A, what will happen? Obviously A's mass will increase. Do not discount electrons' mass. The examiner wants to know whether you understand the concept that electrons are the ones which are moving, and electrons also have the mass. That's what the examiner is checking. Alright, and then A's mass will decrease. That's wrong, obviously. Charges will flow from B to A. Yes, you can see that charges are obviously flowing from B to A, not from A to B. A lot of people feel charges move from plus to minus. Wrong. Charges always go from minus to plus, because it's the electrons which move, protons do not move. Is that understood, everyone? Very good. Chalo, easy question, koi baat nahi. There are difficult questions also. Chalo, solve this question, guys. I'll give you 30 seconds for this question. I'll give you 30 seconds. Come on, solve this very quickly. So what will happen? The answer is it will attract, and let's see why they should attract. See guys, a brass plate, okay, is brought near a charged copper sphere. Doesn't matter whether it's a plate or a sphere, okay. So this is copper and charged copper sphere. So copper sphere is charged, example, this is positive charge, example. Now when you bring them close, what is going to happen? Think about it. When you bring them close, brass is a conductor, so what will happen? Electrons will start moving, guys. Yes, electrons will start moving like this because they will get attracted by this positive charge. So the electrons are going to flow. This side will become negative and this side will become positive. Now think about it. Very, very interesting question, guys. See, what will this negative charge experience? It will experience a force by these positive charges. So there will be a force on the negative charges by these positive charges. What about these positive charges? They will be repelled by these positive charges in this direction. But do you think the magnitudes of these two forces will be same? Will they be? No. Why? Because these charges, negative ones, are closer and these charges are farther apart. So which force will be more? F negative will be more and F positive will be less. Why is it less? Because of more distance between them. So where will the net force be? Net force will be towards the right, and if it is towards the right, what kind of force is between them? It is obviously attraction. So that's what is there between these two. So a lot of people think that since the plate, which is made of brass, did not have any charge but only copper had charge, so a lot of people think this is a neutral body, so the force should be zero, no force. That is wrong. Understand, because of those induced charges, you will see there will be a net force. So that is the concept over here. Yes. Even if brass is charged, still the answer will be attraction, because even the charges on the brass will get distributed such that electrons will come here, protons will be left out bare over there. Still the answer will be attraction only. Okay. So Ratan, what we are doing is, because we saw that instead of the drill sessions which were taking long time, we are planning to conduct Menti sessions in the morning slot for the dropper and the 12th standard. So those are converted into Menti quizzes, and we will be giving you homework questions to solve, which you can see the solutions will be put up in the Telegram group. Okay, so that's what I am planning to do. Yes, Ratan, I just answered you. All right. Okay, so let's go to the next question. And before going to the next question, let's see Coulombs law. So what is Coulombs law? Is very, very simple. Dekho. So if the separation between two charges Q1 and Q2, okay, Q1 and Q2 is R, then the force of attraction or repulsion depends. It could be attraction if it is opposite and repulsion if it is same. So this force is given by K into Q1 Q2 divided by R square. What is this K? It is 9 into 10 to the power 9 approximately in SI units. So you should remember this formula. Very, very important formula. Okay. So very, very important formula, and also important value over here. Direction depends on what is the value of the charges. Alright. So let's go ahead. Okay, if I ask you which force is more, F1 is more or F2 is more, what will be your answer? Which force do you think is more out of these two? What do you guys say? Which force is more, F1 or F2? Both are same or different? Suhas, these are not, you cannot derive. Nobody in this world can derive, Suhas, Coulombs law. These are experimental laws. Hai? If somebody has derived this for you, probably they are lying. Okay. Same, very good. How they are same? Because of Newton's third law. There is no ego between them. That okay, I am big, I will apply more force. Oh, you are small, then I will apply less force. There is no ego between them. They will both apply the same force. Okay, great. Chalo, let's go to the next thing. So force of gravitation. So force of gravitation, which acts between all the celestial bodies like the sun, earth, moon and the sun, everything. So what is the force of attraction? Okay, 1 second guys. Yeah, what is the force of attraction between two masses? Let's say this is M1, let's say this is M2. So So this is the force and this is the distance. So that force is given by a very similar value. It is G m1 m2 divided by r square. And what is this G? G is 6.67 into 10 to the power minus 11, again SI units. Again, you should remember all these values, guys. Okay, so this is the gravitational force and this is the value of G. Is that clear? Is that clear? Insane coder, yes. Okay, is that clear? Shall we go to questions now? A lot of questions coming in only on these two formulas. Just on these two formulas, lot of questions coming in. Okay, let's go ahead. So here is your next question. Let's see whether you can get it. Two small spheres, each carrying a charge Q, are placed r meters apart. Two spheres carrying a charge Q are placed r meters apart. Each charge is Q, understand. If one of the sphere is taken around the other one in a circular path, then the work done by the work done will be equal to how much? Okay, come on, think about it. I'll give you probably just 20 seconds for this question. It's very simple. Come on, very easy, very easy. Yes, many of you have got it. Yes, guys, the answer is 0. Why is it 0? Very easy. Think about it. You have a charge over here, you have another charge here. If you take the other charge like this, there are two ways I can give you the answer. First way, understand the force between them and the displacement will be always perpendicular. And what is work, guys? Work is force dot displacement. So you can obviously see cos 90 degrees is 0. So work done everywhere will be 0. Okay, so force between them, it could be attractive or repulsive depending on what the charges are. Okay, I think the charges were like, so the forces will be this way. Okay, so they will repel each other. So force is always going to be perpendicular to displacement at every point in that circular motion. So work done will be 0. That's a simple way. Second way is remembering what is electrostatic or gravitational force. It's a conservative force. Remember conservative force? Very good force, non-evil force. So what happens when you bring back the point to the same place, original location? What is the net work done by conservative force? It's 0. So if you remember that property, conservative force, and remember electrostatic, gravity are all conservative, the answer is obviously 0, even if it was not circular. Yes, even if the path was not circular, if it was some weird path, even then the work done will be 0. Very good, very good. Chalo. So that was the concept I wanted to convey from this particular question. Let's look at the next question. Let's see how many of you get this. Very interesting question. I will give you 1 minute after I read the question. The gravitational force, this is slightly average level, it's not so simple. Force between two bodies is F. Okay, between two bodies is F. If the mass of each body, what is the mass? I don't know, but whatever is the mass is doubled and the distance between them is halved, then the new force between them will be how many times the previous force? Starting the question now. Conservative force is a special force. If somebody did not get it, Mohammed or somebody, so please watch Mohammed, the separate lecture on conservative and non-conservative forces I have conducted. You can check it out in the playlist in work power energy. I think it was lecture number 2. So lecture 2 of work power energy which I have conducted on Enthuse. Just check it out. Okay, you will get it. Is that okay, Mohammed? Very good. Chalo, hardly 10 seconds. Let's see. I don't know what the option is. And time is up. And let's see how to solve this. See guys, we know that the force is proportional to m1 m2 divided by r square, correct? Now think about it. The new force, if I call it F1, what will it be? It will be, okay, let's do one thing. Let me put over here G, okay, that constant. So the new force, each mass is doubled, that is what is given. So it will be 2m1 into 2m2 divided by, but the distance between them is halved. So r by 2 whole square. So just recalculate this. 2, 2, 4. This 2, when it goes up after squaring, will become more 4. So it will become G m1 m2 by r square. But 2, 2 and 4 from there, you will get it as 16. And what is this G m1 m2 by r square? That is nothing but just the force and into 16. So the force will become 16 times. That's what the answer is. 16 times. Simple? Okay, so that's how you get it. Very interesting problem, and that's the answer to this option number C. Very good, guys. Amazing. Now let's scale it up a little bit more. Let's scale it up. Any guesses how many times is the electrostatic force more by as compared to the gravitational force for protons? Do you have any idea? Okay, let me give you an idea. So the thing is, oh sorry, the question is how many times is the electrostatic force as compared to the gravitational force between two protons. So two protons are positively charged, so they will experience two kinds of forces. One is electrostatic force of repulsion, and the second is obviously the gravitational force because of their masses. Now let's calculate each of them and see what it is. I'll just tell you how to do this. You can do it later on also. Fe, force of repulsion, will be K. K is 9 into 10 to the power 9 into Q1, Q2. Well, Q1 and Q2 both are same. It's 1.6 into 10 to the power minus 19 whole square divided by distance. That is something which I don't know. I'll just leave it over there. Next, what will be the force of gravity? That will be 6.67 into 10 to the power minus 11. And what are the masses of proton? That's already given. It's 1.6 into 10 to the power minus 27, but that is whole square, and that divided by again r square. Now when you divide both these quantities, guys, when you divide both these quantities, what will you get? You will get Fe by Fg, and the best part is this r square and this r square will get cancelled, and even this partially will get cancelled, like this 1.6 and 1.6 will get cancelled. You can do that maths and you will see what the answer is. Any idea? Any idea? Any idea, guys? Okay, I'm reading your chats. Any guesses how much this answer is? It's going to be huge. It's going to be huge. So let me tell you what the answer is. It comes out as 1.36 into 10 to the power 36. That's huge. 10 to the power 12, if I'm not wrong, is a trillion. 10 to the power 12. 10 to the power 24 is a trillion. 10 to the power 36 is a trillion. So, approximately speaking, the electrostatic force is a trillion times more than the gravitational force. That's why we neglect the gravity between two charges when they are very close by. Alright, so that is the logic, and that's why electrostatic force is a much stronger force between subatomic particles, the atomic particles and all that. It's a very strong force as compared to gravity. But if you talk about what is the electrostatic force between moon and the earth, well, that is hardly anything. So for large distances, electrostatic force loses its value. It's the gravitational force which is more important. Is that clear? Yes. Now, let's see what is the answer for this. Quickly read the question. I'm not going to read the question. I want to see how you read the question and solve the question in 1 minute. Are you guys ready for the challenge? You have to read because I want to see how you interpret, because when I read you might get some hint. Let's do that. 1 minute for this. Because it's very simple. Come on, post your answers guys in the chat box, I'll read it. Come on, Jyotkar, Prajwal, Nijarsan, Sanspriya, Mohammad, Devendra. Come on, everyone. No, Mohammad, I don't think so. Think again. No problem guys, you are allowed to make mistakes over here. It's okay. You can make as many mistakes as you want. But give me the answer. Come on, 10 seconds hardly. Oh my god, 144p. Yes. The answer is, guys, what is the answer? The answer is a big fat 0. Why is it big fat 0? You should have thought about it very easily. 3 equal masses are placed on the vertices of an equilateral triangle. M, M, M. Another mass is placed here. What will happen? This mass will be pulled here. This mass will be pulled here. This mass will be pulled here. All these forces are equal and the angles are also equal. So what will be the net force? Obviously 0. That's it. It just looks big. This is a big question, but the answer is so simple. These kind of questions have a special name in JEE. You know what these questions are called? You know what these questions are called? Bouncers. No. Bouncer is something which you don't understand only even after reading 100 times. What is this? What is this? What is this, guys? I hope you got it. I hope you got it. Alright? And in case you did not get it, others please explain them. Yes, these are bananas. And what do Pandus like? What do Pandus like? Bananas. So this is a Hawa banana question. Unnecessarily big question, but there is nothing in this. It's very simple. Alright? So don't get scared. Next question. Before that, let me give you all the formulas. Electrostatic force due to solid sphere. When the charges are distributed everywhere. When the charges are distributed everywhere, what is the answer? And same formula is there for gravitational force due to solid sphere of mass m. There is no difference, guys. Completely solid. So what is the formula? Okay. So understand, there are two parts of this. One is when you are outside. So when you are outside. So then what is the formula? Let's look at that and let's assume that the charge over here is Q. And the second formula is when you are inside. So when R is less than R. Alright. So let's see both the formulas. So when you are outside, what is the formula? The entire thing behaves like a point charge. So just think of it like a point charge separated by how much distance? R distance, small r distance. So just think of it that way. So you will get it as K, Q, Q by R square. So that is the answer only when R is more than or R. Okay, so that's how it works. Now, when you are inside, it is slightly different. So the formula, derivations are all there in H.C. Verma and your NCERT books. It is slightly different. It is K, Q, Q divided by, there is capital R cube here and small r over there. So that's when you are inside. Okay, that's when you are inside. The same formula is also there for gravity, guys. Instead of K, you will have G. Instead of Q and Q, you will have M and M. That's all. That's the answer. Remember this. So, when will this work? This will work. Very good question, Suhas. So, this will work when this is an insulator. When this is an insulator, only then the charges can be distributed inside. So charges are also inside. So this is a uniformly charged insulator. Why only insulator? Think about it. If this was a conductor, what will happen, guys? All the charges will just come outside. That's it. All the charges are going to come outside. Only on the surface. So it will behave like a shell. Are you getting it? All the charges will just be on the periphery. So this will only work when it is an insulator. Yes, very important. Absolutely correct. So guys, now you know the formula for gravity also. If you want, I'll just write it for the heck of it, so that you know it's there on the board. You can copy it down. So the force will be G M by R square, but this is when R is more than R, and this will be G M small r divided by R cube, but this is when R is less than R. You can copy down these formulas very quickly. It should be there in your notebook. All important formulas I am giving you for this chapter. Keep it going, guys. Keep writing. Very important formulas, very similar to electrostatics. Then hollow sphere, very important. Again, hollow sphere, guys. So let's talk about hollow sphere. So if you have a hollow sphere or solid conducting sphere, both are the same thing. Why am I saying even a solid conducting sphere is same as a hollow sphere? Only for electrostatics. Why? Because for solids which are conductors, all the charges, remember, charges are on surface. That's the only reason why I'm saying that. Okay, remember, it's very important. Now, very important formula that I'm giving. When you are outside, when the charge is outside, this distance is more than R. And second point, when you are inside, when R is less than R. So let's see what the formulas are. So when you are outside, guys, the formula is still the same. Think of all the charge concentrated over here. Distance is small r. So two charges separated by distance r. So K, Q by R square. So this is when R is more than R. And when you are inside, then the answer is big fat 0. So no matter where you are inside, then understand the net force will be 0. Okay, remember this. Devendra, gravity is very similar to electrostatics, but all the satellites and Kepler's laws, I will keep a separate lecture for that. Don't worry, okay? Because all other things are similar, so you should understand it together. You can kill two birds in one stone then. Okay, this is another important formula. Same thing is for hollow sphere of mass m. There is no difference again. Okay, so it is force is Gmm by R square, and it is 0, but this is when R is more than R, and it is 0 when R is less than R. Same formula for gravity. There is no difference. You can see that. Okay, small r is, remember, this distance where you are placing that mass. Chalo, let's go to the next formula. Ring formula, guys. Ring formula. What is the ring formula? So let me tell you. When you have a charged ring, then what happens? This charge will get pulled from different charges all over here, like this, because the charges are over here, right? Like this. So all these points will pull it in different directions, and you will see that the net resultant will be along this line. If it is opposite, then it will be attractive. If it is same, then it will be repulsive. But whatever it is, the force will be along this line. So this is the net force. And if you are at a distance x, this is a ring. Remember, this is the axis of that ring. Okay, this is the axis of the ring. Then the formula, guys, I hope you remember. The net force which acts on that charge is K, capital Q, small q, divided by, I think there is an x over here, and I think you have r square plus x square whole raised to 3 by 2. That's the answer. How do you remember it? I remember it because if I put the value of x as 0, that means this charge will come over here at the center of the ring. Correct? If x is 0. So what will happen on this charge? All the charges on the ring will push it, okay, and they will cancel out all the forces. So what should the force be? 0. So I will make the formula in such a way that if x is in the numerator, then obviously the force will be 0. That's how I remember it. And I know that there is something like 3 by 2 in the denominator downstairs. Moment, you can see the derivations in NCERT and all that. So since we are doing it in a little bit fast mode for all of you, I want you to remember all these formulas. You can see all the derivations and all the things in NCERT. It's all there. It's by vector addition. You just take all the forces, resolve the components, and only consider the horizontal components. That's all. That's how it is derived. Okay. Very similar to, yes, these formulas will also come in magnetism. Very good. And same thing for ring. There was one problem I had seen long time back. There was this Saturn given, and the Saturn planet has a ring. The question was, if there is a mass over here, what is the force due to the ring of that Saturn? That was the question. That was the question. So you can use the same formula what I gave you just some time back. Is this understood? How this formula is useful? Yes, gravity. So again, the gravitational force, assuming this distance is x, is given by Gmm by again x and r square plus x square whole raised to 3 by 2. That's what you should remember. Very important formulas, guys. Very good, very good. Yes, all the formulas are needed for NEET, JEE, JEE Mains, JEE Advanced, BITSAT, CET, boards, everything. All the formulas which are essential. Next, this is a very interesting problem. I'll just solve this, and the next question is a homework problem for you, and you have to post the answers in the comment box. I will check out all the answers what you have given in the previous lecture also, and I'll also post the solutions of the previous lecture's homework problem very soon, in a day. Just give me a day's time. Previous lecture ka bhi homework, I'll give it to you on the Telegram group. Remember, nowhere else you will get these solutions. So you have to join the Telegram group. Yes. Okay, now here is the next part. Mass of 1 kg is divided into 2 parts. So imagine you had this mass of 1 kg and you divide it into 2 parts. How? X kg, and the remaining as 1 minus x kg. Now the question is, the force between them, which will be there, gravitational force, will be maximum if x is how much? How much should be the value of x so that the force is maximum? How do you solve this question, guys? What do you guys suggest? Come on, come on, come on. Okay, what is the answer, guys? And how do you do it? What is the value of x so that the force between them is maximum? Coulombs law. Okay, let's apply Coulombs law. So Coulombs law says G, it's not Coulombs law actually, it's Newton's law of gravitation, very identical but still. So K Gx into 1 minus x divided by r square. Now think about it. If force has to be increased, I want to make it maximum. G can't be changed, R can't be changed. So what do I need to maximize? I need to make these terms maximum. In order to maximize the force, I need to maximize x into 1 minus x. Is this clear till this point? What do I need to maximize? Now, here is the logic. Isn't this a quadratic equation? Can't you see this is like a quadratic equation? Check this out. What this exactly is, you will be able to see. This is nothing but minus x square, correct? Minus x square plus x. This is that quadratic equation. So how do I find the maximum value? Haven't you learned this, guys? Haven't you learned this? How do you find? This is first of all, what kind of parabola? This is this kind of parabola because the coefficient of the square term is negative. So what is the when is the value maximum? When is the value maximum? For what value of x? Come on, think of this. For what value of x do you think it is maximum? Minus b, which is 1, by 2 into a, which is also minus 1. So what is it? Half. So that's the answer. That's the answer. Not 4a, guys, it is 2a. Half is the answer. That's how simple it is. See how quadratics is useful here. What an amazing way to use this. Such a nice question. Did you see that? What an amazing question. Yes. So if the masses are half kg and half kg, then the force will be maximum. If it is 0.25 and 0.75, it will not be maximum. It will be lesser than that. If it is 0.1 and 0.9, it will still be less than that. You can try it out and you will see that it will always be true. Okay, great. Now, this is the best question. I'll just give you a hint for this question. This is a question on double star system. You have to post the solution in the comment box below. Okay, answer, sorry. Alright. So these are nothing but two stars revolving around each other. That's called as a double star system. And they revolve around their center of mass. So if you have forgotten the formula of center of mass, please attend my class yesterday. I have completed center of mass in previous session yesterday. You can find it out in the playlist of Enthuse channel. So just check it out and use the concept that if two stars of mass m and 2m and radii r1 and r2 revolve around a common center, what will be the speed of the stars? Actually, I'll modify the question a little bit. Instead of giving r1 and r2 respectively, okay, what is given over here is distance between them is r. That is what is given. So all your answers will be in terms of small r, m, 2m and g. That's all. Nothing else in the answer. The question is, what are the speeds of the stars? What are the speeds of the stars? That's the question, guys. So let's see how many of you get it. But this is not the correct diagram. These are elliptical orbits. The correct diagram, this is when the orbits are ellipse. But in reality, if I take circular orbits, both those orbits will be like this. Okay, so m will be here, 2m will be here, and their center of mass will be here. So both of them will be revolving like this. So this is your diagram. This was just another diagram when the orbits are elliptical, but our orbits are usually not elliptical in JEE questions. So in JEE we generally have circular orbits. Understand that. So this is your diagram which you're going to use and solve the question based on this diagram. Alright, chalo. Let's end the lecture now, and in case some of the dropper students are present here, or 12th standard students are present here, some of them are asking, sir, is there a course only for droppers, like a crash course? No subscription, only crash course, little bit cheaper. We have heard you. Yes, there is just a course only for droppers or for 12th standard students who want to crack the exam and without having the subscription, and that course, guys, is available for 8,000 rupees. The coupon code for that is SHCC. It is SHCC, and instead of 10,000 you have to pay only 8,000 rupees. It's only crash course. Yes, only crash course, nothing else. So that is a very sasta course, very cheap course that you are getting only for 12th and the dropper students. If you want to revise and you want to get into the paid sessions and you want all the benefits of test series, doubt solving, assignments, numericals and all those things, then this is the course for you. Yes. No, that will be different, Suhas. It will be something else. It's not for 4K, it is for 8K only. It's not possible. You can find it and let me know. It will not be possible. This is the lowest price possible. Alright? Okay, so Can a class of 11 could watch your courses who haven't started kinematics? Kaur, I would suggest you please watch those kinematic courses and then you attend. That will be better, but you can definitely watch. But in this free time, whatever you get, please try and watch those kinematic sessions. Alright? And the solutions of the homework question will be put up on the Telegram group. So watch the Telegram group, guys, very carefully. Okay? And if you have loved today's session, I have covered so many concepts, so many questions. If you have loved it, then please hit the like button. Only if you hit the like button, I will understand and I will get energy. I will be enthused about conducting more such sessions. So guys who are taking a drop or in 12th standard, come on, if you want more such sessions like this, and even the 11th standard students for KVPY, you want these sessions, hit the like button, and also do not forget to subscribe. Without subscription, no point. Alright, so that's it for today, guys. Thank you very much. Thank you very much. Take care. Bye bye. See you. Have a great time ahead. This was Shreyas here, your master teacher for physics at Vedantu. Signing off. Bye bye.